Hello learners, welcome to today's class. So this class is from MCS 221, which is a part of data warehousing and data mining course, and today's portion is taken from block 4 unit 10. So if you remember, in the last class we have covered frequent pattern mining and their applications, and we also covered the different algorithms associated with that. We talked about a priori algorithms. Not only that, we also tried to understand the a priori algorithm with the help of an examples, and we had a further discussion on how the a priori is going to be much faster enough or not. Today's session, I'm going to talk about classification and prediction, and where I will be covering about the introductory part, followed by what is the difference between supervised and unsupervised learning, and what are the different terminologies we are going to use in the classification. Then we will differentiate between what is a classification and what is a prediction is basically, and followed by what are the different applications we have for the classification process. And then we will also talk about the in classification what exactly happen is it's basically a two-step process, and followed by different issues regarding classification and prediction. So if you remember, the data mining is a part of knowledge extraction which are hidden in your databases, and we already covered the different functionalities like association rule and all. So today's class is basically another functionalities of data mining, which is a classification. So what happened in the classification is we try to predict the class, we try to predict the future trends using these classification techniques and all. So if you look at this beautiful quotes, predicting the future is not a magic. It's basically a artificial intelligence, which is said by the Dev Water. It's basically using a artificial intelligence technique, and today's topic is very much relevance with predicting the futures. Sometime we are going to predict the weather forecasting, sometime we are going to predict whether the student is going to pass or fail, sometime we are predicting whether the tomorrow is going to be rainy or sunny day. So all those applications comes under the classification process. So if you look at the different form of knowledge discovery, we already saw the association rule. Classification is another most commonly used technique where it comes to classifying the large set of data. And usually we use two forms of data mining or data analysis technique, where we try to describe the important classes or we try to predict the future trends. For example, if you want to classify the student according to their qualification, so what exactly we are going to do is based on the different features or different attributes, we are going to classify the student according to their qualification. Now all this application, whatever I have spoken, basically what is happening is machine is trying to predict. So whenever the machine is trying to predict, that means we have to train the system. We have to give some kind of training data set to the machine, and based on those training data set, we actually try to predict the futures. So in literature, we have two different types of learning. One is a supervised and another one is a unsupervised learning. Classification process, which is a type of supervised learning, so that means there is some kind of supervision is there, and based on those supervision, whatever the classes of observation we have, along with whatever the class we are going to have, so all these data will be fed to the system, and this is basically a training set. Whereas you have an unsupervised learning where the class label of training data set is unknown, and usually we use these techniques in clustering techniques, and where we have given a set of measurements, observation, with the aim of establishing the existence of classes or clusters in the data. So in case of clustering, these class labels are not known. And when it comes to the classification, all these class labels are known. So what do you mean by class label? For example, if I say the student is going to pass or fail. So in that case, pass and fail are the two classes, right? And when we supply the data set to the machine, that is our training data set, all these data set or all these class labels are known to us. For each input and each row, whether the student is pass or fail, that is given and that is known in case of classification. Sometime in literature, we also have a third types of learning, that is what we call the reinforcement learning. In that case, what exactly happens is another area of machine learning, which is concerned with how intelligence agents ought to take action in the environment in order to maximize the notation of cumulative rewards. So basically what is happening here is your intelligence agents are trying to make some kind of decision where the situation is not known, because for many of the data set we know their class level is known, we know that their class level is unknown, right? So instead of this, what happens in case of reinforced learning, they try to find the balance between the exploration of this uncharted territory and known territory, that is a current knowledge what we have. So based on this reinforcement learning, we also try to give some kind of optimal decision to the system. So after understanding the very brief about how the system is going to be learned, whether it is going to be a supervised learning or whether it is going to be unsupervised learning, so what we are going to do is we are going to use the different classification techniques or different clustering techniques. As I mentioned, in case of classification, your class labels are known. That means there is some kind of supervision is there while you are providing a data set to the machine or your system, right? Now let us look at the different definitions which has been used in the classification techniques. So we use classifier, which is basically some kind of algorithm which is going to map the input data to the specific categories, right? We have a classification model which tries to draw some kind of conclusion from the input values given for the training data set, and based on that it will predict the class labels categories for the new data. So basically what happens is whenever you have a unknown data, like what happens is once your system is trained, so unknown data will be given to the system, and based on those unknown data it will try to predict whether it is going to fit into the class A or class B or class C, right? That is what happened in the classification model. So we are actually building a model where, for example, in case we want to predict the student is going to pass or fail, so we have already given a training data set to the system, and with all the training data sets we are supplied that they are going to either pass or fail. And now whenever we have a new entry of the student, and that we are going to predict whether it is going to pass or fail. Other than that, we also have something called as features. So feature is another term which we use very frequently in the classification or machine learning environment. So feature selection or feature analysis, which is basically your attributes, right? It's a individual measurable property of phenomena here. And if you look at the database, or if you look at the database tables, so for example, if we were talking about the student database, so you have a student enrollment numbers, you have a student subjects marks, subject 1 marks, subject 2 marks, subject 3 marks, and so on. All these subject 1, subject 2, subject 3 marks are the features. They are the attributes. And based on these attributes, what we are going to do is we are going to train the system, and that is how the classification model is going to classify whether the student is going to pass or fail. Another frequently used term in the classification is binary classification. In this binary classification, you have only two possible outcomes, right? Either 0 or 1. That means suppose you want to classify a gender classification, right? So we know that either you have a male or female. Sometimes you have a third gender also, but again it's based on our system whether you want to give male, female, or maybe other categories here. So generally in the binary classification you have a two possible values, either yes or no, or 1 or 0. Other than this, you also have a multi-class classification here where you can have more than two classes. For example, if you talk about weather prediction system, right? So weather prediction system, you may have one of the class as sunny, another class as a rainy, third class as a windy, fourth class as cloudy, and so on, right? That means you have a multiple classes, and in multi-class classification each sample is assigned to one or only one target label, right? And based on this, what you are going to do is, again you are going to give these data sets to the machine for the training, and once your system is trained, then what you are going to do is you are always going to predict the system here. So an animal can be cat or dog, but not both at the same time. That is what the example of multi-class classification we have given. That means each sample has to be assigned to only one target label only. Other than this, sometimes you have a multi-label classification where classification task, each sample is mapped to set of target label where you can have a more than one class. For example, you have a news article which can be about sports or a person or location at the same time. So in this case, you are mapping a set of targets to the different labels here. That means more than one label. That is also possible here. Now let's understand the difference between the classification and prediction, because most of the time what we do is we always get confusion whether we are actually using the classification model or we are actually using the prediction model. So one very clear difference one can see in the very first line here. In case of classification, it actually builds the classifier or kind of model based on the categorical labels, right? Categorical labels where you have it's not a number here, right? And whereas we talk about prediction, a model or predictor will be constructed is based on the continuous value function or some kind of ordered value. You have a numbers system there, and based on those numbers, what you are going to do is you are going to build this model or predictor here. So that's the reason we call it as a predictor in case of prediction. In case of classification, that is known as a classifier here. In case of process of identifying which category a new observation belongs to based on a training data set which contain the observation whose category's membership is known. So that is what we have defined in case of supervised learning. So we have a training data sets where the class label for each sample is known, right? And based on that, whenever any new observation is coming or new data set is coming, based on your classifier or based on your classification model, what you are going to do is you are going to assign to that particular class. In case of prediction, process of identifying the missing or unavailable numeric data for a new observation. And in case of classification, accuracy depends on finding the class label correctly, and that is one of the most important what you call factors, like whenever you are building a classifier or predictor here. Accuracy, based on this accuracy, you always try to improve the accuracy by adjusting the different features or by adjusting the different factors. For example, in case of classification, the grouping of patients based on their medical records can be considered as a classification, whereas we can think of prediction as a predicting the correct treatment for a particular disease for a person. So that is how we try to differentiate between classification and prediction here. So one thing to be noted here, in case of classification, categorical values has to be there. In case of prediction, you have a continuous values data or a continuous values function to be used. Now let's look at the different applications, though I have mentioned the application of student prediction, weather forecasting system, but there are numerous applications available for this classification model. One such model is predicting the cart analysis based on the electronic commerce platform, which uses the classification techniques to associate the item into the groups and create the combination of product to be recommended here. You must have observed this, like whenever you go to the Amazon site or Flipkart site, and whenever you purchase one item, there is always a list of items at the end of the page, which always says that the person who has purchased this has also purchased this. All that is possible with the help of these data mining techniques. All that is possible with the help of the classification model we are actually using. So Google actually uses different techniques, or these Amazon or these different companies actually uses a different classification model techniques, and based on that the actual recommendation has to be given to the system. Another thing, I was talking about the weather prediction here. So weather prediction can be predicted and classified based on the parameters. So you know that there are multiple factors involved, like temperature, humidity, wind direction, and many more, right? So based on, if you have a known, all these parameters are known to us, and based on this, what we can do is we can assign all these data sets to our machine, and based on those data set we can actually train the system, and we can actually predict the weather, whether it is going to be rainy, or whether it is going to be sunny, or whether it is going to be cloudy after 1 week, or maybe very next day, depending upon what kind of system you are actually building. Next application what we have is a public health sector here. So where we are classifying the disease based on the different parameters like a spread rate, severity, and lot more here. So basically what is happening is the doctors, it is helping to the doctors, which is actually helping to take what kind of mitigation, what kind of strategies to be taken to solve that particular, or to give some kind of what you call medicine to the patient here, right? So based on all this classification, that is also possible here. Another things what we have is a financial institute which uses classification to determine the defaulters and help in determining the loan seekers and other categories. For example, let me talk more on this. Like you have a classification model where one person wanted to, he wanted to apply for the loan, right? Now, because whenever the financial institution or any other bank are going to provide a loan to the person, they actually look the different data such as what is your current salary, is what is your credit ratings, and so on. And based on all those factors, they actually try to build the classification model and says that whether the person is actually going to pay EMI on time or not, right? So that is another field where the classification model, or where the data mining techniques on the whole is being used, and they are actually using and try to give the loan to the only potential customer who can pay the EMI on time. Another important thing, I think this one is everyone must have experienced this. Like everyone uses the Gmail, Google mail ID here, right? And you have a different folders to the left hand side. So you know that whenever you receive a mail from the unknown source, usually it goes to the spam folders, right? So whether the incoming mail is spam, yes, or not spam, right? How this is going to be classified? So classification techniques, it uses different classification algorithm. We have many such algorithm which can be used to predict whether the given mail is a spam or not, right? So that is another typical application of classification, where we can use this classification system to predict whether the given email is spam or not spam. Another typical application, we have many applications. So we can classify the patient according to their medical history. Classification can be used to approval of the credits. We can have a facial key point detection, drug classification. In case of automotive car driving, where we have a motorless, driverless car, where we have a pedestrian detection, they actually uses these classification techniques, sentiment analysis, cancer tumor cells identification, and many more. So different applications are there in daily life where we can actually use these data mining techniques, or in particular classification techniques, to predict or to classify them in a particular class or not. Now let's understand, like after understanding the basics about the supervised learning, unsupervised learning, and typical application, let's understand how this classification works. So basically classification happens in the two steps. The first step, what we have is a model construction here, and the second one is how we are going to use the model. So model uses is another step here. So let's look at the step one here. So in step one, what we are going to do is we are going to construct the model here. So we have a set of what we call training data set. Predetermined classes are there. So what we have is each tuple or the sample data is assumed to belong to a predetermined class, right? And this class we have already discussed. I said whether the student is going to pass yes or no, right? Or pass or fail could be a two class here. And based on this set of tuples used for the model construction, what we use is the training data set. So what exactly happen is you have an input data set, and this input data set is actually divided into two parts. So one is a training data set and second one is a testing data set. And the division rules again depends on your different parameters. Sometimes people divide 70% of the data for training data set, and rest 30% they use it for the testing the data set, right? And the whole model, if you are using the classification model, it can be represented in a various form. We can use the classification rule, we can use the what we call mathematical formula, and we can use some kind of classifier model basically, which can be actually going to help you for constructing the model here. So after constructing the model, the second step says that what we have is how we are going to use the model here. So that means in the model usage, what we are going to do is we are going to classify the future, or what we are going to do is we are going to classify the unknown objects here. So this can be done by estimating the accuracy of the model here. So this accuracy rate of the percentage of the test sample that are correctly classified by the model here. So if it says the higher the percentage, better the model you are actually building here. So if you have a model which is actually giving you 80 to 90% of accuracy, that means this is somewhat better here. And based on this test data set, what we have is what we are going to do is we are going to actually build this model and not. Now understand the same model construction and things with the help of an example here. So you have a training data sets. For example, you have this based on the classification algorithm. What we are going to do is we are going to build the classifier here model, and this model can use some kind of classification rule and all. And once you have trained the system, what you are going to do is you are going to use this, right? So you have a testing data set, and based on this testing data set, what you are going to do is you are going to use the classifier, and this classifier you are going to apply on the unseen data, the class level for whose sample is unknown. For example, if you have a Jeff and a professor and his standard number of experience is 4, so we have to predict whether he is going to be tenured or not, right? So based on the whatever the model we have built, in this case you can actually see that it is going to actually predict the model as yes. So if you look at the screen, you can see that based on the whatever the model we have built, the model is predicted based on the testing data set. There are various issues which are involved in the classification and prediction here. So not only for the classification, in the data mining on the whole, we use various data preparation techniques where we talk about data cleaning, relevance analysis, because in real-time data they are very, very noisy. That has to be handled, that has to be, noises has to be clean. We have to use the data transformation techniques. And once we apply all these techniques, that means we have to prepare the data sets. And after the preparing the data sets, what we are going to do is we are going to finally build the class and use the training data set for the further analysis and all. So what we are going to do is, this is what we have discussed today. Classification model, and the classification model was discussed. Supervised versus unsupervised model learning techniques was discussed. And in the next class, I'm going to take one of the examples of classification, where we will see with the help of an example and try to understand the classification model. Thank you.